Hi everyone, this is Steve on the Guru Brew. Today's class is about the hard drive and how it works. This device lives inside your computer and it records all the information that goes into the computer that you put in. And then when the power is out, it retains the data and then it recalls it when you ask for your data back. So this is your main storage box right here called the hard drive. Now that solid state hard drives have come into fashion, I'm pretty sure they're here to stay. And as the prices come down on the solid state hard drives, these will eventually go extinct. These have been around since the 1950s and little has changed. Some improvements have been made, but they're basically still the same. I have a box here of hard drives I'll show you. Most of the hard drives in this box I've saved. They're a little bit too small for most modern computers, but they're still useful and they do work. What's inside these and how do they work? Well, I thought I would go ahead and do a video and explain the various parts to you and show you the inner workings and maybe fire one up with the cover off so you can see how it works. So in this edition of the Guru Brew, the anatomy of a hard drive, coming up. Okay, well, I have a hard drive here. This is a Seagate hard drive, and I've started to take some of the screws out of there so I could show you. Most of the hard drives that I've encountered take a special kind of screwdriver bit called a security bit, and you can see I have a set of them here. I picked this out, set up at a hardware store, and it has a whole bunch of different security bits in it, and this is the one here. I don't know if you can see that, but that's the one that took these screws out here. And generally there's a label that covers the top of this that you have to remove before you can get the screws out, and you know it hides under there. So we'll open that in just a minute. The first thing I wanted to tell you is, if you want to experiment with your own hard drive, do not do this to one that you care about or one that you want to work again, because these have to be opened in a clean room, 100% rated clean room, and if you do not, the minute you take the cover off and expose the platters to the dust and debris just of the air, it will render it useless. Anybody that works on these has to have a special clean room that's actually even cleaner than a medical room, I'm told. And the slightest bit of debris can damage them, just so you understand that. So there's external parts on these as well as internal. I'll show you the external first. This circuit board right here contains all the main components that run the hard drive itself, and it's called the logic board, and there are a few other components inside it, but most are mechanical. This is the bulk of the electronics right here, and you'll see how it connects to the actual chamber in just a moment. This hard drive is called an IDE hard drive because it works off this ribbon cable, and it's one of the most common types. There's also SCSI and SATA connectors. You'll find that on most all hard drives there are 3 banks of connectors on the back. The first one is for our power, and that goes into here. And then this second one is a jumper for our configurations. I'll talk more about that in just a moment. And then this is our actual interface block, and this is the one that runs on the cable, the IDE cable. So let's flip this over and begin talking about some of the parts and how they work on this circuit board. The main controller of this circuit board is here, and this controls all aspects of this hard drive. It allows it to talk to the computer, as well as tells the motors to spin up and where to move the heads and that sort of thing. So this is the main controller. Over here we have what's called a buffer, and it's basically just RAM that is located here, And depending on how much RAM you have on your hard drive will change the performance. Just like in a computer, if you were to put memory in it, the RAM is a main component in defining how fast the hard drive can read and write. And then right next to the main controller here, this is a flash memory, a little IC package here, and its job is to hold all the information that the controller needs to run. And oftentimes if you update your controller, you'll be talking to this chip directly. This is flash memory, so it's not usually meant to be rewritten, but it can be. Okay. This little component over here is the motor controller, and it takes instructions from the main controller that are provided by the memory from this, and then this actually controls the motors and the heads here. Okay. There's a few other various parts in it, but that's the main parts that allow this thing to work. Okay. I want to show you this little sticker right here that covers up this hole. This is actually an atmospheric pressure equalizer, and you can see that it goes on to the inner chamber, and if there's a difference in pressure, this sticker can slightly move without compromising letting air in. Is how that works. Let's go ahead and take this controller off here and get a look at the let's go ahead and take the circuit board off here and get a look at what's underneath it. Again, I'm using that special bit. When they build these hard drives, they build them so that the circuit board and all the parts on the circuit board can be taken off and easily serviced without compromising opening the hard drive, because I told you before it's really sensitive to dust and that sort of thing. Okay, so there's the circuit board there that we discussed, and there's just mostly traces here on the back. But you can notice that this area right here are the pins that connect to here that allow it to talk to the inners of the hard drive here. Okay, and then there's a pin connection here as well that allows it to talk to the motor, the spindle motor that allows the hard drive to turn. So, you know, that mates up perfectly, just like brushes on a motor. And this part could easily be interchanged, although that's not always a good idea for somebody that really doesn't know what they're doing to do. So that comes off like that. So I wanted to talk a little bit more about this jumper. Now, this is typically found in an IDE drive, which this is, and the cable is so too. And there are usually 3 different configurations that you can get out of moving this little jumper on these pins. The first one would be master, second one would be slave, and then cable select for the third one. Let me explain what those are all about. Like I said before, this drive, this IDE drive, is hooked to the computer with this IDE cable here. And you can see that this IDE cable is marked. There's a master, slave, and then the CPU board is on the end here. And the first pin is designated with this red stripe that goes along the cable. So depending on usually where you have this cable plugged into is what the drive becomes. So if you have a computer that has multiple hard drives in it, it can actually share the same wire, okay? So if I have this jumper set on cable select, whatever plug I have my hard drive into, if it be master or slave, the drive will become just that. So if I have this set on cable select and I plug it into my slave here, then this drive becomes a slave, which is secondary to the master. Generally, slaves or secondaries are just data drives and do not contain an operating system. Usually the master is the one that contains the operating system. However, if I move this drive over to here, this drive would now become the master if this was set onto cable select. Okay. Now, please remember that cable select only works if you have a cable select compatible IDE cable, and not all IDE cables are cable select compatible. If I just had a regular ribbon cable and I set this jumper over to master, it would not matter if I had this connector or this connector. This drive would still be master regardless of which connector I had it hooked to. If I was to move this jumper over to the slave side, again, it wouldn't matter if I had it hooked to slave or master. It would be slave if this jumper was set for slave. So that's what the configuration pins do. There's usually 3 configurations. SCSI hard drives, which are normally found in servers, do have other configuration pins for their device and ID numbers, which is beyond the scope of this lesson and usually not found in consumer products anyway, so I won't cover that now. If there is an interest, let me know in the comments and maybe I'll cover that. So that's how the pins work. Okay, so let's flip it over here. And I've already taken the screws out. This screw was protected by a sticker that I took off, and then the other screws were removed with this special tool here. Inside here, you'll find the platters. Now this is a very small hard drive, so there's only a single platter, and if I turn it up here, you can see that there's just one disc here, and that's what the platters are called. It's a magnetized piece of metal or glass that is in a disc shape that spins. Something that's kind of neat here is this item right over here, and if you can see that, it's like a little filter. Let's see if I can pull it out. And this little filter is responsible for keeping the particles down. Once it spins up, if there was anything inside here, this would catch it as far as debris or dirt. Like I said, if there's any little speck of dirt or dust in here, it will cause this to crash and make it useless. These heads here on this arm are what read the disc, and they actually cruise above the disc on each side of the disc. And they don't touch, they almost touch. There is an air gap, I think, of about 10 nanometers between them. And it works by picking up the magnetic signal, either plus or minus polarity is how it works. The arm here is controlled the same way that a speaker coil would work, and it's actually a voice coil type configuration. There's a magnet of rare earth quality on the top and one on the bottom, and then this arm has a coil of copper wire on it, and when the electricity is introduced into the copper wire, it positions this according to the logic. And like I said, it's based on the voice coil. If you've seen a speaker, how they've got a magnet and then they've got a coil, and then the head moves in and out for the bass and treble. This is the same principle. It will just move like this. And we'll plug this in a minute so you can see it work. And you can see the ribbon cable that goes to the arm. And they, like I said, this is just a single platter, but they do stack these up, and there can be 3, 4, 5 of these inside here. And there's all very high quality ball bearings down in here, and underneath here there's also a coil of wire that is energized, that is the actual motor for this, and these typically run at 5400 RPMs, 7200 RPMs, and 10,000 RPMs is typically what a desktop will run, and then a laptop usually runs around 4200 RPMs. So really, in a nutshell, the way that this works is instructions come in from the computer through this circuit board that we took off here, and this chip right here processes the signal, our main controller, and then it sends signals to our motor here through this chip that allow this to spin and turn, and it also positions our heads which read. Okay, and this head is either reading or writing. If it's reading, it's hovering over this magnetic disc and it's getting ones and zeros, and if it's writing, of course, it's magnetizing this disc in different polarities to represent ones and zeros. It's a very simple device, but it's a very exact device, and the tolerances are incredibly strict. These heads that fly above these platters are designed to self-right themselves, and I think the distance between the head is only, like I said, about 10 nanometers, which is very small. Let me go ahead and put the circuit board back on this, and we'll plug it in and we'll see it run without the cover on it. Okay, I'll be back. Okay, so I'm going to go ahead and hook this the power supply I have here. I've got this power supply sitting over here that I use. I'm just going to hook it up to my hard drive here without the cover on it and see what happens. Here we go. So the thing that's moving back and forth is the arm and the head, and it's trying to find home. It's trying to find the master boot record is what it's trying to find, which gives it instructions on how to boot. This disc is definitely damaged because we opened it, and you can see all the fingerprints on the thing. So it just spins for a little bit, then gives up. Let's turn it back off and turn it back on again so we can watch it one more time. So once the disc gets to speed, the arm begins searching. And then when it can't find what it's looking for, it just gives up. If you've ever heard that clicking noise on your computer, that's a bad sign. That means there's errors and it's probably going to fail soon. So that's a telltale sign that you have a hard drive problem. Okay, very good. Let's go out for some final thoughts. Well, there you have it. That is my little spiel on mechanical hard drives. You know, I was just thinking a couple of years ago I wouldn't have had to say the word mechanical hard drive because it went without saying that all hard drives are mechanical. Just within the last couple of years, solid states have taken over, and for good reason. I mean, they're super fast, super reliable. The only problem with them right now that I see is their price, and I expect that to get better really soon. So I guess in the title of this video, I'll call it Anatomy of a Mechanical Hard Drive. That way in the future it'll make sense to those that are using solid state hard drives that never knew what a mechanical hard drive was. It probably will go away just like the beta or VHS tapes. So as usual, thanks for watching. You never know, I might take apart a solid state hard drive at some point, even though, you know, they're not going to be as exciting as a mechanical, I mean, really, they're just RAM and a controller, so I don't see much more than that to look at. But if you want to see it, let me know in the comments, and please give us a thumbs up. It matters to us. It really matters when you thumbs up. It helps our popularity out on YouTube, and it helps us grow, and it puts a few dollars in our pocket that we can use for the show here. So I'll see you next time. Bye for now. Hey guys, this is Steve. Thanks for watching. Hey, don't forget to subscribe if you like this video, and be sure to rate and comment. See ya.